And you,
Hmm?
I have something to tell you.
Mm-hmm.
So we might have noticed that when playing the game. I also had a star on which ones have been swapped.
Yeah, I noticed all that.
And
Yeah. So those are
and
things that are really nice.
and I also coded something myself where it detects duplicates and it randomizes it again if it detects it.
Nice. No, I didn't give it a deep drive. But what I saw, I liked very much. I'm pretty sure Ryan also liked it, and I kind of lucked out with just 5. But you guys can play around and try and make everything configurable, bring your own taste to it. But that's all, right? We're not going to go any deeper into this game because there's a few other things that I thought I could probably go over before the end of the quarter. Sorting. Yeah, I'll talk a little bit about sorting today, especially since you did the sorting game. So I'll talk a little bit about sorting, but we won't belabor sorting anymore because you will learn a whole lot more about sorting in just a couple of quarters. Not even a couple of quarters. Next quarter maybe, right? Isn't 2B? Yeah, actually, no, we don't cover sorting in great detail in 2B. A little bit more, but not in great detail. But in 2C, we do cover sorting in great detail. You also get to do a quest based on sorting, which is really cool, right? So right now, I'll just basically give you an overview. What you implemented is a way, not you didn't implement a sorting technique, right? In this game, we didn't implement a sorting technique. Oh, by the way, before we even start talking about this, I wanted to, if I forget my train of thought, bring me back into sorting, okay, later. So the one thing that I wanted to bring up, now that enough of us is here, Ben, yeah, okay. Ben is basically double dipping with 2 screens, so I think more people are here than Ben is also a car person, Chad. So you got a friend for your racing game, or your Grand Prix. Okay, so
you probably aren't surprised to get the picture.
Yeah. All right. So anyway, next Tuesday, March the 2nd. I have some personal stuff to attend to, unfortunately, between, not unfortunately, but, I have some, meaning that I got to take some time away from you guys. So I'll be off. I'll not be online from, I don't know, maybe 8:15 until about 9:15 for an hour. Okay. But I want one of you guys to basically lead the class during that time, which essentially is, during the first 15 minutes, we'll come up with a couple of activities. And especially the person who's volunteering to lead the class needs to be there with me during that time, even if nobody else is there. So we go over what needs to be covered, what you can play with. I'll give you a bunch of marbles basically during that time, and then this person will basically not lead the class really. Essentially, everybody's going to work through some shared window, like we usually do in class. As people pick some idea related to what we're talking about. Someone is going to code. Someone else is going to, type it in maybe, or call it out, type it in, and the person who volunteers to coordinate the class is just going to not chaperone, right? It's just going to coordinate the activities, right? Or even call out the code if the other person is stuck, and so on. Basically ordered play, right? You guys get 1 hour of ordered play time on Tuesday. Is that okay? So I'd like for that person who coordinates the class to be one of you guys, but also the person who calls out code. All right, so no coordinator, more co-coordinator, right? So I think one of you who's already coded before should except not maybe not Chad or some of the other people who've just gone on screen before and had some stage time. Okay, no, so Chad, not me, obviously, not Chad. Okay, anybody else volunteer to promise, right? Not promise. Yeah, I can hold you to it, but you're basically saying you will make sure that you log into Zoom. I'll log into Zoom at 8 a.m. right? Open up the meeting. And then maybe hand over the host controls to someone, okay, and then take off for an hour. Is that okay with you guys?
Oh yeah, sure.
All right. So can someone volunteer to? Well, you can just volunteer in a personal message too. That's fine, right? So if you want, just email me saying that it's just 1 hour you're going to drive And if you're afraid, you shouldn't be afraid, right? So it's basically just an opportunity to see what it's like, right on the other side, to say, when you have all these eager students trying to code, and it's a very, very likely scenario that the person who's coding could get super excited, which always happens, right? It's super excited and basically lost in their world. Okay, so they lose everybody, like Chad, right? So they just get so enamored with what they're doing, and they forget that there are people around us. I lose everybody, and and that's likely to happen. And so you'll get to observe that from from the other side, and say, okay, well, when I'm on that side now, I know what to do.
I can do it. What time do I need to join?
Join at 8 a.m. sharp.
8 a.m. Okay.
Yeah.
All right.
So what'll happen is that I'll be online from 8 a.m. to around 8:10 or so, and then we can have a conversation, or whoever, right? So and then we'll brainstorm a couple of problems to work through, right?
Sounds good.
Thank you, Nate. Thank you. All right. So coming back to sorting. So like I said, this sorting is an entire universe of topics. You can basically just go pick and choose. And what we did in this game that we built was basically, or at least what I tried, was not a sorting technique, right? So this game was not a sorting algorithm. What you did was, it's really cool, because you laid the foundation for what could potentially be any damn sorting algorithm, but a comparison sort, right? Because comparison sort is a sort where the only thing you can do, you got a bunch of items, right? And you don't know what the items are. So this is when it comes to sorting, things are so interesting, because this whole family, it's like, biologists, right? So they have taxonomies, so everything, the human mind is obsessed with taxonomy, right? And putting things into boxes and categorizing things, right? So and so we have these ontologies of knowledge, and in biology we have these things. And sorting also, you have these taxonomy of sorts, and then so there is a whole family of sorts that you can do really, really, really efficiently, far better than any published algorithm, right? Far better than any linear time, even constant time sorting algorithms are available if you know something about the domain that is so critical, right? So if you know something about the domain, you can engineer kick-ass algorithms that'll basically knock everyone out of the water, right? That's the power of domain knowledge. So typically computer science is not to do with, and that's the beauty, right? So computer science says, well, there's these few people who have domain knowledge that can basically rule the whole world, right? Because they know exactly what's going to go on. But what about the vast majority who don't have domain knowledge, right? How can their lives be improved? So computer science really I think is in many ways a way of approaching technology or science such that you can still win or get the best of what you can without the power of domain knowledge, right? So, and that is why we're having this really interesting discussion about splay trees in CS2C. And where was I going with that? I know where I was going with that, but certainly you can bring domain knowledge. There is, right? So using domain knowledge, you can do really powerful things. Even with sorting, right? But what can you do if you didn't have domain knowledge, right? If you didn't have domain knowledge, what's the best you can do? And that is real computer science, right? So because you're saying, I don't have any advantages. I'm going to play on a level field with everyone. And what is the best I can do? Right, and then splay tree says, there's a data structure. So, I'll give you logarithmic time complexity without having to have bookkeeping, amortized. Right, so over average, over a long time, I'll give you on average logarithmic time complexity. This is really reasonably efficient, right? As efficient as you can get otherwise, without immediate bookkeeping, right? So which is a pain to, housekeeping is always a pain, right? So this is data structures. And this is powerful data structures that are meant for specific things, and all these nuances we get to appreciate. Anyway, with sorting, and so with domain knowledge, you can do crazy ass things. But the power of sorting, the juice of sorting is to do mostly, right? Mostly, because if you, without the domain knowledge is where the real juice of sorting is, because there you have to bring your own ingenuity into bearing, right? You can't depend on domain knowledge to save your ass. right? You can't say, well, I know this particular thing, and knowing that, I don't have to do anything at all because, it's solved. The problem is solved for me. But these poor, ignorant fools, they don't know this, critical thing. And so they're slaving away their entire lives, right? And because I know this, and so if you didn't have domain knowledge, there you are. And sorting, what we're going to say is, well, okay, we didn't have that domain knowledge, but still we have what is called human ingenuity, right? So we have human ingenuity with which we can say, even if we didn't have all these advantages, because what is the chance? What is the chance I would have ended up with that piece of knowledge that allowed me to solve this problem so easily? Right? So if I look at it, it's really a chance occurrence. And if it's a chance occurrence, it may not have happened to me. Well, and what the hell would I have been doing if that didn't happen to me? Right? I would be slaving away like everybody else. So I need to find a way to solve this problem, even if that really brilliant stroke didn't happen to me. Yes? And that is computer science, right? And that is really science. And science says, well, is there a way in which we can improve the human lot, even if some crazy ass thing that is, as of now, unpredictable, right? Didn't happen. Even if that didn't happen, how can we make the best of what we have? And if you study sorting, all of the secrets are hidden right there, because that says, okay, the only thing I need to know about the external world, right? If I'm given a bunch of things to sort, right? And it's like the Buddha, right? The Buddha says, people come to him and ask these crazy ass questions about, when was the universe made? Or, is there a God? And things like that. And he says, well, hold on here, but let's tackle a more fundamental problem, right? So is this going to improve your life or not? That's really what we're going to ultimately after, right? So like that. And so sorting says, we have a bunch of things and you're asking me to sort it, right? You're asking me to prioritize things and order things and say, this is more important, or this is, this has to be higher and that has to be lower. So there is this magic order that I haven't discovered. It's buried in there. It's the golden order. This game that we're building is this golden ranking in there. It's buried in there, but I can't see it. It's in there, and I have to discover it through careful experimentation. Now, so if I, at that point, say, well, you know what, in order for me to rank these things properly, I first need to know what these crazy ass things are, right? What is the first item? Is that a player? Oh, okay, they are player objects. Okay, now, player objects, before I rank all these players, I need to know, does this player have a nose, right? How many eyes do these players have, right? Does they have 10 arms, 15 arms? I need to know all these details, right? How high they are, right? Who their parents are, all kinds of details that probably are maybe some of them are irrelevant, right? Maybe this player doesn't have any arms at all, so they can't play baseball, right? So, but maybe you ask totally irrelevant questions and say that I'm blocked in my task, right? You're asking me to rank these players. However, you're blocking me in my task when I try and find out more detail about these players. So, and that is a perfectly natural, very, and I shouldn't say natural, it's actually unnatural, right? But it's a very common kind of argument you hear from real life people all the time, right? So when you ask people to do something and they come back with a totally unrelated reason why they can't do it, right? And you say that, well, that really is not a reason why the task can be done. It can be an excuse for not doing it, but it's not a reason for the task not being done. Guess how many of us have come across, situations where that happens, right? We know that's what it is, but you don't have to treat it like that, but we know what it is, right? So, so sorting, the essence of sorting says, right, okay, well, you're asking me to sort it, and I'm not going to do, and I'm going to do my job, right? I'm just going to do my job, I'm not going to do any more. So I don't need to really know. I don't need to know the nitty gritty details of how these people are living their lives, right? So, yeah. So all I need to know is, given two people, who needs to go on top and who needs to go on bottom, right? That's the only thing I need to know. If everybody I ask tells me, right, if I give you two people to compare and you say, well, two things to compare, and you say, well, that one has a higher priority than this, that's all I need to know. Right? I don't need to know any further detail. Now, that kind of a sort is really the most powerful, I shouldn't say most powerful, right? Because with domain knowledge, you can get incredible power, unimaginable power sometimes, right? Because, without domain knowledge, you can't even imagine the possibilities. But once you have domain knowledge, you say, oh my gosh, wow, there is actually a linear solution to this, right? All along, I've been thinking it's a quadratic solution because I never even saw the linear solution, right? Because that linear solution was completely out. It wasn't even a possibility in your mind, and you never even saw it. And when you see it, because you have the domain knowledge, you say, well, I can solve it this way. And then, and so what happens is that in sorting, and you say, well, with sorting, the only thing I need to know is, and that family of sorting is called comparison sorting. Okay, comparison sorting is such a rich family of algorithms that do the best trade-off between the amount of work they do and the amount of information they need to know. Right? Then that's the best way to run an organization too, right? Because that's in fact, that is the heart of C++. You think about it, right? That really is the heart of C++, because C++ says you can do far greater things by refusing to know all the nitty-gritty, shitty detail that I'll take away from you and basically shield you so that you won't even see these things. There's a lot of power of assembler and even C, right? There's even a lot of power of the raw compute power of CPUs. It's out there for you to use. But if you're going to focus on the whole power of the CPU, you're never, ever going to get any real work done, right? So C++ comes in at a very strategic time, right? Between the rays of light leaving the CPU and your brain, right? So it comes in as a very strategic time and says, okay, I'm going to shield the power, the sheer power of the CPU, because here's like Jack Nicholson says, right? Here's the truth, but you can't handle the truth, right? So I'm going to shield it, right? So I don't know which film it is, but it was a very nice line, right? In one of those movies. A long time ago, right? So and the CPU, C++ says, okay, I'm going to stand right here and I'm going to shield the power, because you can't handle the power. You can't see the truth, right? However, what you do need in order to make your own life successful, I will basically pass through. Right? And what is potentially possible to enrich your life, but also has a greater chance of basically ruining it, right? I'm going to make it harder for you. Not impossible, I'm going to make it harder for you to actually see, right? So C++ is a selective lens over the CPU. if I'm the perspective that I'm looking at it, right? So other people might have different perspectives. But the power of C, it says is a perspective lens that says the full power of the CPU is in fact available to you, but I am basically going to enhance certain powers to you and basically dim certain other powers. So you have to peek harder to see the dim parts. But I've over several years of experience, right? Over decades of experience, the parts that are letting the light through and enhancing have evolved, right? Over being trimmed and pruned and basically enhanced and polished and so on. They've pruned so that only the really useful parts of the CPU being exposed, those lenses in the part in the C++ language, they're over C++ 14, 11, or 17. I don't even know what the details of 17 right now are, but really the details of the standard, it's the result of lots and lots of intelligent people thinking about it and saying, well, this is what we find most useful. So those are the aspects of the CPU we need to emphasize to the user to make it easy for them, right? And so maybe later on, if let's not go into speculative territory, right? So comparison sorting. So what we did, and so it struck the balance and said, okay, when it comes to sorting, this is the work that needs to get done, and this is the amount of information that needs to that this person can ask about the domain. And obviously, every question you ask really of the customer is a costly question, right? You talk to real life organizations too. Right, that is basically a calculus that I bet if marketing people adopt, I think they will actually find quantifiable success too. Right, so in fact, every question you have to ask your customer is a really costly question. But you can have any number of questions inside. Right, inside your organization, you can have questions. You can fight with each other, and anything can happen. But the customer only gets a unified thing, and also communicating with the customer is expensive. Right, it's expensive compared to internal communications. So, and I think it is very similar with algorithms too, right? When you have to process data, right? Anything you do inside of your algorithm itself is fine. You can do a lot of stuff, right? I mean, your algorithm, you polish and so on. But every time you need to go and fetch data, more data, or look at data, or get more information about data, right? Not the data items itself. Get more information about the data. That's really expensive. So that is why you get a bunch of numbers. That's really easy. But you get a bunch of numbers with metadata, and metadata pointing at various places and saying and giving explanations and annotations. That gets really messy, hard to process, and it's also tough to So that's why. I don't know where I was going with that. So getting metadata is always hard. So and so the best sorting techniques say I'll try and do the job with as little metadata requests as possible, which means that all I need to know is not even the actual data items. I just need to know if two items are comparing in a particular way. That's all I need. So imagine, right? So they're asking for one bit of information. They give you 2 items and they only ask for 1 bit of information in return. 1 bit, not even 1 byte. It's 1 bit, right? 1 bit of information in return. And we're saying, just give us 1 bit of information in return for 2 items I give you. That's all. And I will basically give you this thing. Does that make sense to you guys? I don't know. Nobody's talking. I know, it was basically was I on mute all the time? Oh, hang on. No, actually, I wasn't on mute. But in fact, if I was on mute, I'd be very surprised if you guys didn't point me out that I was just moving my lips. Hang on, there's actually 4 messages in chat. Maybe that's what you're trying to tell me. Oh, yeah, okay. I'm sorry. Yeah, domain knowledge is basically when you know something special about the data. Right? And in fact, there is a quest. There is a quest called Curiouser and Curiouser, right? I actually named it after Peter, who was really, really curious about stuff that I was giving him. But so this quest is called Curiouser and Curiouser. Now, try it out. Try it out. It is actually a log linear problem, which basically says it's not easy to solve it in linear time if you didn't know something about the domain, right? And so it is actually possible to solve it in linear time. See, it's much faster, right? I would say it's like yeah, it's not like the drop from quadratic to log linear, but certainly yeah, much faster, and with the domain knowledge, with knowing something about the numbers, you can actually make it far better, far faster. So I encourage you to try that quest if you're well. I think last quarter when I made the quest, I also gave people a prize. I think $150 or something. I don't know if the contest is still open, but try and do it without. Yeah, if there's sufficient interest, we can turn it into another contest. Okay, all right. So so the worst case sorting, and this is something that you guys can potentially even discuss next class, right? When you guys are on your own sorting. So the bubble sort is really the worst, right? Because what I did was basically take this guy, compare it with everything right above until I moved to the top. But really, I didn't have to. Maybe I didn't even have to compare it with everything, right? Maybe I could have just compared it with the first or the or second or third. So I could jump further, right? The risk with jumping further is that maybe I've jumped too far. I don't know if I'm nobody's even chiming in by verb, or let's say I'm talking to you, right? We're sitting on a bench and we're talking over a drink or something like that. You wouldn't let me talk without even giving me some feedback that you're listening, right? Or nodding your head or saying or something like that. So this is not very conversation-like. When it's feels like a monologue, and I'm basically giving you a diatribe about what I believe, and you guys basically just tune out because you don't agree with me, right? And that doesn't seem.
Yeah, I agree. Sometimes you kind of do that if it goes on for too long, right?
No, but you could basically say yeah, or something like that, just to make sure that you guys are still here, right? Because I don't want to be sitting here talking to myself, right? I can just talk to myself in my head.
Yeah, I'm here. Don't worry.
All right, thank you. Anyway, I lost my train of thought. What was I saying? The sorting. We were talking about sorting. So anyway, what you guys have built is basically is not a sorting algorithm, but basically the Turing machine of sorting algorithms. Essentially saying, yeah, it's a Turing, because you have a bunch of things and you need to sort it. Let's say not 5, maybe 10 or 10,000 n items, right? N items, and you got to sort it and. And you've provided the machinery. You've provided the machinery by which you can take 2 out, examine, to put 2 back, right? And then by doing comparisons, we get the right answer. Yeah. So you've provided the machinery to let the user compare items and sort it. And the thing is, you've said the challenge is sort it, and you only have 1 superpower, right? So sorting is a task, and the superpowers are the bits of information you give them. And the only superpower you get now is the basic superpower, which is give me 2 items and I'll tell you which one is better. right? And maybe, you know, if the game gets going and people are interested, you say, well, you know, you've earned, now you have 15 player to sort, 15 races, 15 cars to sort, but you know, you can't do that using ordinary sorting techniques that you're using right now, right? Bubble sort, take a long time. However, you can do it efficiently if you bring in some domain knowledge, right? How can you get this domain knowledge? You can get this domain knowledge by earning these superpowers, right? So maybe one superpower is a piece of you know, sacred knowledge that tells you all those numbers are less than 100. Okay, so you know, something like that. You know, some domain knowledge.
Yeah.
Now you say, wow, okay, even if you give me like 50,000 items, now I can still sort it in linear time, right? Because now I have this very crucial piece of information, right? All even numbers, or something, right? So you can come up with these really clever little pieces of domain knowledge that increase the odds of picking a clever algorithm that incorporates that knowledge. Yeah. So the brute force algorithm, and by doing that, you'll also learn about different sorting techniques, right? And not only that, you'll also learn about non-conventional, non-comparison. You know, it says comparison sort. So the non-comparison sort, because non-comparison sort is where you use a sort, but also use domain knowledge to, you know, do crazy things. So you learn these two and say, well, you know, using this piece of knowledge is like super duper powerful, because if I told them, maybe there's a, you know, a piece of knowledge in there that says how close a list is already to be sorted, right? How close the list is, the distance between this list and the golden list. Maybe you quantify that somehow and maintain it in a variable in your game, right? And maybe that's a secret piece of knowledge, right? But if the user happens to know that, if the user can actually secretly through you see that difference between the golden list and your list, and they find that it's actually 0, then they say, well, you know, I can accomplish this task in better than constant time. I can accomplish this task in 0 time, because I know without doing anything I say, it's already sorted, right? That's not even O of 1, right? It's O of 0.
Yes.
I don't know, there's nobody's talking about O of 0 time, but basically that's what it is, right? So O of 0 is when you actually solve a problem without having to solve a problem at all, right? O of 1 is when you can solve a problem in constant time. Right? O of n is solve a problem in linear time, meaning the more you have to process, the more effort you have to put in, right? Quadratic time is O of n squared. Remember, quadratic algorithms, the more items you have, the effort you have to put in is the square of the number of items you have. You have cubic, exponential, it's all kinds of crazy, right? So O of 0 means no, right? No, 0 effort and the problem is solved. And so how cool is that? So if that is the power of domain knowledge. So if you can peek through the system and say, well, you fought all the mini bosses, and then the final boss is really hard, right? But if you solve the final boss, you can solve the problem. Okay, so like the Ganondorf of Zelda, right? So you get to the final boss, and the final boss, after being vanquished, right, it reveals the secret. The secret is that the golden list is the same as your list, right? Okay, and then you know, right? You say instantly you've solved the problem without doing any work at all. So how cool is that? Right, so you can pick and choose these little jewels, right, that you hide in your landscape, and say, you know, in my game that I'm going to design. Well, obviously, right, we're talking now about an ASCII game like this, right? But it doesn't have to be ASCII. What I'm saying is that learn about Unreal or Unity, right? You can build the same thing with, the heart of it is basically what the algorithm that you built. Right, but you could basically skin it differently with 3D immersion, all these things, and you can make drag contestants into plays and add all kinds of effects, right? And you can make people discover the intricacies and nuances of sorting without actually learning computer science formally, right? They just enter your world and play this game, right, and come up with these crazy techniques and earn these secret nuggets that they find here and there, right? They find these secret nuggets of pearls of wisdom, right? They find these pearls of wisdom right here and there that give you a little bit of domain knowledge. Let's say, right? So you have different gradations of players, right? So the newbies who don't have any of the secret knowledge, and they're still just slaving away doing n-squared algorithms, right? So, and then you have experienced players using n-log n algorithms like quicksort and so on, and saying on average we're the best we can do. And then we have like people super duper experienced players who done quicksort for long enough, and they've also uncovered the landscape, the little jewels here and there, and they also have domain knowledge at their disposal, right? So they bring everything to bear, and all of everything together, and finally you can have an adventure that ends in Ganondorf that reveals the final secret, right? So you can do all these really cool things, and you say, take it away. You can brainstorm all these in the next class too, right? So, yeah.
So I have a question.
Yeah, sure.
So wow, that's interesting. you know that when we make our game and how you sort, can it actually help you create good sorting algorithms?
Who?
I'm talking about, other than like, for example, the inefficient bubble sort.
What time is it now? 8:40. Hey, Chad. Let's carry on that conversation offline.
Cool.
For
I was
sure.
actually waiting to code.
Yeah.
Yeah.
No, we won't. Let's not pick up that code again. So what we'll do, it's fantastic. It blossomed in the way that I wished it would. So it's made all of you so excited about computer science, and you're talking about interesting stuff, right? That's really what I want, right? I don't care if you guys get A pluses and so on. Honestly, that's nothing for me, right? But if you guys just get fired up and start talking and come up with these interesting ideas, that is like, it's really worth putting in the time to teach you guys.
But I think it's possible that, based on what I learned from this game, maybe I could create a cool sorting algorithm.
Yeah.
That actually is intelligent. So it's a lot more efficient than bubble sort.
I did, brainstorm all these things later, right? Brainstorm all these things later. What we'll do now today is let's pick up someone who can drive today, take the screen and drive, and open an editor. And I'm thinking today what we can do is we won't, sorting is on your own. You got to find out more. This, it's very simple. We've described all this in the modules, and I hope this is, a mini lecture I gave about sorting and the things about sorting and behind it and domain knowledge. Was that useful at all? Did it help you? I know it's not really part of core CS2A.
Yeah.
Anyway, thanks. So what we can do today is when you pick up the screen, you can, let's play with some search techniques, okay? So I think let's do, I will do really quickly. You can do linear search and binary search, yeah? Because sorting, I think you can pick up by yourself. Linear, I think let's do linear and binary. We should do that in less than 10, 30 minutes, maybe 30 minutes. And then today, maybe you can do binary search iteratively. So you also get an idea, right? So that's a good intuition about what binary search is. And then next week, this is week 8. No, this is week 8, right? I keep losing week count.
Yeah, I think so. I think it's week 8.
And it's Thursday too. So we have 9, 10, 11, 3 more weeks to go. So next week I can talk about recursion, right? This is a very fun subject because then after I've talked about recursion, we had a chance to play with recursion. We can pick up our binary search algorithm, which today we'll just do iteratively, right? And then turn into a recursive binary search. Okay. So that should be next week, I think. Next week we can cover both recursion and search techniques. And then that only leaves week 11 for stacks and linked lists. So it's involving pointers. Yeah. Is there anything else you guys want to learn in CS2A that I might have probably missed? I'm happy to talk about that. Or if you want extra lectures too, I'm happy to schedule extra lectures. Yeah, let me know. Did we cover so far? Have we covered all the material that is sufficient to keep you let's say in a situation where you find all the quests and all the things that you need to do easy enough?
Yeah, definitely.
Thanks. Also, you just let me know, right? If it's too slow or too fast, also you should let me know. All right. So why doesn't someone pick up the screen and then we'll start coding. What time is it now? 8:45? Yeah, we got 1 hour. So yeah, there's plenty of time. So what we can do is we can start coding an algorithm. Yeah, well, we're going to do linear search first, right? So let's create a vector of, let's say, 100,000 numbers. Okay, 100,000 random integers. Let's put in 100,000 random integers. This is 10,000, right? 10,000. So we can continue to use random, right? 10,000 random integers. So let's No, actually, let's do a let's do 100,000 random integers. Okay, run 100,000 random integers, and then we can do and make sure those random integers are in ascending order, so we don't mess around with sorting, right? So we know already that when we create the vector, it's already sorted. And then let's use a usual loop with the user, saying where the user can say, is this number in the vector? Is this number in the vector? And the answer will be yes or no, because they're all random, right? So there's going to be holes, right? From numbers from 1 to 100,000 maybe, right? And let's say they're numbers from 1 to 1,000,000, okay, in 100,000 pigeonholes. So which means there's going to be lots of holes between numbers, right? So the user may ask for a number that's not there. Yeah, I think this is exactly the same as the pet. I'm thinking about the same thing. Yeah, I will do something. We'll do something. But basically we need a vector of objects, and then yeah, we'll play and find out, right? We'll let the situation guide us. Okay, so who wants to take the screen and drive? I think Fear, Fear has been on the screen before, right?
Yes, I've been on the screen before.
Yeah.
I have been on the screen before.
Yeah, you have. Yeah, well, you are just last class, right? You're not going anymore, Chad, this quarter. Okay. So it's let's see. I don't know who wants to go.
I can go, but I've been on screen before, and I'm gonna do that, and I'm gonna do that next class. But I can go now if you want.
How about so you're gonna go next class? How about Robert? Okay, Robert, do you want? Hey, Ben, do you want to go? Ben, you got 2 screens. I'll guide you through the whole thing.
I could go if nobody takes.
Okay. All right, Robert or Michael. Oh, Ben says, let me think. So if he wants to go, give him a chance. Otherwise, you can go, Robert or Michael, okay. Whoever you. Yeah, one of you. All right, Robert, you can go. So Ben says in the chat he wants you to go. Robert, so you can take the screen.
Hang on, let me.
Yeah. Now, so I know that Robert also, like chat, types at the same speed as I'm talking, and chat goes faster. That is even more of a problem, right? So, Robert, but other people, I want to make sure that if you think that I'm talking too fast or Robert's typing too fast, you got to tell us, okay? Otherwise, it'll just be like the 2 of us doing some mini project, personal project here. Yeah or no? Yes or no?
Yeah.
Okay. All right. So the rest of you have to pipe up and say, "Hey, guys, slow down," or don't go faster, or something like that. Okay. All right. So let's just go open up an editor or open up some a new file. Yeah, let's get the template code. And yeah, okay, all right, so let's try this. So I wanted to try this yesterday, but I didn't get a chance. So all right, so let's say we want to create a class, right? Right on top of main. We want a vector of objects, not just a random, we want a vector of objects, right? So we'll keep 2 things in there. So let's create a class on top and say class. Let's see. Person, yeah, class person, and give them a string name and a long ID, a string name and a long ID. Right. In fact, you know what? Here's a trick. Instead of saying class and public every time, one thing we can do is basically, instead of class, just make it a struct. Right. Instead of turn the word class into a struct. right? Now, struct is a from a remnant from the distant universe, right? It comes from C, and struct says everything in here is public, right? It's just a class, but everything is a public. Right? A struct is basically a class with everything public. That's basically it, right? So so get rid of the keyword public. And then a constructor maybe and then we need we need two members, right? So string name and string name, just give a string name and then a size t ID, right? And then close it. We don't need methods or constructors or anything. So we'll, because it's everything is public, we're just using the class, in this case everything all public class, a struct as a struct as a bag, as a container, not for any specific purpose of attaching a function and running things on it, right? We're just using it as a container so that we have one convenient bag to have both the person and the corresponding ID. Otherwise, the alternative in the historical past is to have two parallel vectors, right? One vector is called names and the other vector is called IDs, and they both have to be parallel and lined up, right? So if I want person number 57's name, I go to this vector, ID number 56, right? Or, you know, the whatever, right? So locate 57 here, and that has to line up with that here, that the 57 ID here, the element of 57 and the name of 57 have got to be the same. You can already see that is really messy, right? Because it's two different things, and we're trying to say that really it's the same thing. We're trying to create this illusion that there is this person item, and C++ says, no, forget about the illusion. Get the two and make it a single packet, and so you can have a vector of one item, right? And so, and we are saying that's essentially the functionality we want, right? We're not going to create any new sophisticated methods inside of my class, so we'll just make it struct, because, you know, why call a spade something other than a spade? We'll just say, you know, all we need this for is a bag to have two items. So I need a name and an ID, and I need them both to be together. So instead of having parallel vectors, I'm just going to put them in a bag and have a vector of that item. So does that make sense? It is a very common idiom, and sometimes you may see classes with all public items, right? All public items and no methods. And that is our struct, right? And that is the intention behind the programmer using that particular structure, is saying that, you know, I just need a bag, right? So and then we get very good, very good at recognizing these things and saying, well, you know, that's the programmer uses struct there and not a class. That basically, that means they're just using it as bag, right? Other places they're using a class. Oh, that means they're going to do a, you know, they want a bag, but they also want methods to do things on bag, right? So, yeah, does that make sense? Lots of people don't even talk about these things, but these are actually very important, because once you know these things, you read up other people's code and you come across these, you know, patterns, you instantly know what's going on, right? Or you basically get a small sneak peek into that person's mind, right? You maybe that's not what they're thinking. There's a very high chance that's the reason why they did that, right? So you get a sneak peek, and the more of these situations you encounter, the more easily you can read other people's code, right? So people always read these big books and say it's really hard to get through these mathematical proofs, or go hard in a big book and a long time, right? That's because they're not able to relate really quickly, right? So, but once you've lived a life, a rich life, in which you've encountered all these different situations, right? You can map these things and say, well, you know, that's what's going on. That's what's going on. Oh, everything. You get through this really quickly, and that's essentially that's what's going on here. Is to say, you know, you pick up these little bits of knowledge which seem like totally unrelated and useless, and it's not even part of CS2A, and it's not part of the state mandate to teach you, right? So we're not even required to teach you. There's this thing called struct, and it's the same as a class with everything public, right? But it's important to know these things if you're going to be a professional programmer. Professional meaning not working for someone else, right? If you want to develop your own thing, you never. Here's the thing, right? What I've found is that, as in my years and years of managing really brilliant software people, right? So what I've found is that there may be brilliant people, but they'll never ever give you the best, right? They'll never give you their best, and that's the same with you too. You think about it, right? You'll never ever give your total best. You'll never give it to someone that is asking for their own sake, right? So you'll only do your very true best for yourself, right? That's when you're following your dream. And that's the way. I don't know how we got started talking about this, right? But essentially, so yes, getting these people and getting the best, getting the best out of people is to get people to be interested and do their own thing, right? So that's what all these big companies do, right? So it says, well, take care of everything you need, right? You take care of everything you need. That way you can just do what you want, right? And so when you do what you want, then you're going to do the best ever, right? It's the best you can do. That's the only situation, right? You're never ever going to do the best for someone who's going to pay you money, right? So if they're going to pay me money, they're going to put a value on what I give them. That's how much I'm going to give them, right? If they're going to pay me $100,000, I'm only going to give them $100,000 of value. I'm not going to give them $1 million of value, Yes, I mean, that's what you're thinking anyway in your mind. So and that is why, you know, the best work you get is really not from people that you buy work from. It's basically just by firing people up to do their own shit, right? So say you know, if I want you guys, if I want to enjoy some absolutely fantastic invention later on in life, right? So if I want to do something really fantastic, right, I want to put on my Oculus and say, I want to enter this world that my CS2A or 2C students have created, right, and lose myself for a whole day, right? So if I have that kind of a dream, right, then my best bet is not to say, well, here's $1 million scholarship, guys, go ahead and do this, right? This is my vision. Never going to happen. Right. So instead, I could say, you know, here's some cool things you can do. Right. So then you'll go and do these really cool things. And then maybe you'll send me a link later on. Right. Maybe 5 years from now, send me a link. Hey, Anand, go and check it out. Right. So then I go and say, hey, guys, you know, and I send you a link 1 year later. Hey, you know, for the whole of last year, I was just lost in a game. Right. So I could say that. And that's really fun. And that's where we're going with all this. OK, so these little things. So struck. I don't know, right? You guys have to ring me in, right? Nobody's even talking. Maybe you're saying this in chat.
Yeah, I understand.
Yeah, but you should tell me if I'm
it's actually
talking away and not really.
It is actually a very good point. That if you get paid an X amount of money, you're just going to most likely give what you believe to be X amount of money's worth of work. That's also why I see people who kind of, let's say, well, people who start their own product or do something that they're genuinely passionate about, they always tend to perform way better than somebody that's just kind of working you know, a desk job that
yeah, agree.
they don't really care about, because they genuinely have passion for it, and they're putting their all into it, and their all is always going to be better than the fraction of their all that they believe that they should give based on the amount of money that they're getting. So yeah.
This is absolutely, you know, because I've seen people in the Silicon Valley, right, and they're paying a fortune. You know, sometimes like I've seen $500,000 go waste being paid to contractors, right, being paid to contractors who are doing a shoddy job. And I can see this is a shoddy job, something that, you know, I could easily do in my sleep, right? So and they've taken such a long time, and you know, many revisions back and forth, and so it's ultimately $500,000, and that's because they're not doing it. They're not, I don't know, they have this vision and they're doing it for someone else, really, right? So you're doing, whereas if this person who was really passionate about the thing, if they learned C++ on, or whatever it was that, right, and they did it themselves, they could have done it for not $500,000, for less than $5,000, right, on their own. It's just, you know, $5,000 of Starbucks coffees and pizzas. I sit down and get a much better product done on your own, right? So, and a lot of people don't even know the amount of work that it takes to get something done. And many people, especially in marketing and other people, they tend to overestimate, right? So they say, oh, you know, that should be worth like $1 million of work, right? So we need a lot of money to get this done. And the truth is that it's not like that, right? So many times it's actually very cheap and easy to do, but many people don't know that it's easy, and that's the problem.
Oh, wow. That's kind of the reason. That's definitely the reason why I think, you know, being talented is a good idea.
Yeah, totally.
Because then, you know those AAA games, who knows that they could be a lot cheaper if you have more of those, right?
Yeah, absolutely.
They could be considered simple, right?
Yeah. All right. Okay. I'm sorry we went into this digression here.
Yeah, it's just, you know, you've been going on for quite a while, so.
Yeah. Hey, Peter, just give me 1 sec, okay? So what we want to do, I'll tell you what we want to do, and then I'll go and, you know, I need to give Peter you need to come back first next. What I want to do is basically an ID, and then in main, I want a vector of persons, and then a loop in which we basically set random names and IDs. We'll just create a function like we did before for making a name and then assigning an ID. We'll basically add on a random number each time, okay? So I'll be back in like 2 minutes, okay? So I just need to, give him a walnut. Hey, Peter. Oh, he ran away. Maybe it's not Peter. Oh, it's the one with the gray. Right. Now, Peter has a reddish tail. This guy has a gray tail. So it's a different squirrel. Okay. All right. That's why he also ran away when I went near him. Okay, all right. Also, I think he took one of my marbles. Yeah, I have a bunch of marbles lying around in my yard, and they've been disappearing. And I just saw this guy running away with one of these marbles in his mouth. So, all right. Okay. Hey, you've not done anything. Okay. All right. So let's say a person. Yeah, let's get rid of the constructor. Let's get rid of the constructor in line 6, and basically say string name. Get rid of the string constructor. I say string space name, and then on the next line, just say size t ID. Right. So it's just a bag. We just created a bag. Called person. Okay, so now we have a vector of persons called persons. So on the next line, let's do a simple for loop, a blank line there, blank line, and then let's do a for loop for size t I equals 0. Oh, let's resize it, right? So let's say one line before that, yeah, say, yeah, resize. Let's say 100,000. Let's have 100,000 people, right? 100,000. Okay, 100,000, right? All right. In fact, I think that could even be folded into the constructor itself, right? So on the same line as a vector person persons, I think within parentheses, if you say 100,000 there, you can actually say, let's say, yeah, you can actually say 100,000. What I do, right? And you can do this if you think it makes sense. So whenever I have a number greater than 1,000, right? I write it as 10 times 1,000 or 100 times 1,000, because it's very easy for, it's hard for us to count the number of zeros, right? It's something exploited by all the spammers or the trolls on these forums, right? Who pick names with O's and zeros, so you can't report them to the moderator, right? So. Or easily anyway. Yeah, but don't do that, Ben. All right, okay. So
I think there's a way to delineate the zeros in C++17 or so. If you just do like a single asterisk, like a single tick or something between the zeros.
I see. Yeah, I don't know, but there's all kinds of tricks, right? This is L and 1, and they. But I've encountered difficulties one time, and not anymore, right? One time in the distant past, when I had a spammer and I just couldn't report the spammer to the mod. Okay, so for size t I equals 0, I less than well, should we say 100,000, or let's just create a constant size t and in the very first member of main, right? And so the very first line of main, right? On main, you can say const size t size equals 100 times 1,000, and then everywhere else we can just use that uppercase size.
I think I might have seen that in Java. It actually, I think I seen that in Java. This is known as a final variable.
Yeah, const is basically a final variable. Yes. Yeah. So now all we need to do is basically cycle through each of those persons and set the name and set the ID. So what we'll do is let's say what is it? What persons of I, persons square bracket I dot name equals make name, right? Make underscore name, and maybe let's say we pass the parameter I. So I just had an idea, right? So we can try that. Okay, we'll pass the parameter I. Okay, now next line, person of dot ID equals. Now what we want to do is we want to do the previous ID plus a random number between 0 and 10, meaning that we make sure that every ID we assign is bigger than the previous one. No, not even bigger. It could be the same, right? Plus 0 could be the same. So we want to make sure it's not less than those. So we want to make sure it's in non-descending order. So what we want to do is basically before the for loop, create a variable just before the for loop. Blank line there. Yeah, say size t previous ID equals 0, right? And then here you can say previous plus rand %, let's say 10. So each ID should be a random number more than the previous ID, which means that we'll have 100,000 different, potentially different IDs, because some same ones, non-descending IDs, but also there will be a bunch of IDs, a whole bunch of IDs, 90% of the IDs in the space will be missing, right? Because just jumping at a time. So we don't have, there's not a high degree of certainty that, you ask for a random number, it's in there. Yes or no?
Yeah.
Okay. All right. So so we do that. Now at the end of that for loop, we should have a vector with all of those IDs in there. So let's do a make name. So I'm thinking we'll do this, right? So there are these 7 musical, so what is this? Do, re, mi, fa, sol, la, ti, right? So let's say a string. Was it vector of strings? Yeah, it was a vector of strings. Vector of strings. String. Syllables equals sills. So yeah, so whatever you can pick the name. So equals, and then initialize that with the names of those notes: do, re, mi, fa, sol, la, ti. So you got 7 of those. R-E, yeah, no, I think it's R-A. No, is it R-E? R-E, is it? R-E, isn't it? I don't know, some guy who knows.
Yeah, it's R-A.
Hmm?
It's R-A. No, R-E.
Okay.
Sorry, I kind of mispronounced it.
So S-O, and then L-A. And then the last one is T, I think, T-I. Okay, now we just pick 3 syllables from here at random. Syllable 1 equals syl of rand %7, or syl of rand %syl dot size. String syl 1, or return. Syl square bracket. What is it? Yeah, rand %, rand syl dot size, and then a plus the same thing 3 times, so we get 3 syllables. One more time, the same thing, right? Syl of rand %syl dot size, the same thing. No, you need to close the square bracket there, and then the plus. Yeah, okay, now the whole thing over again. So I think that should give us some reasonably interesting names. I don't know if we'll get a million different names, but we'll find out. It doesn't have to. The names don't have to be unique. So that's good. Yeah. So the names don't have to be unique, because we've made sure the IDs are unique. And you got a typo, so. No, you got too many of those, right? You got. I think you got too many of those, Robert. So yeah, make that syl. Yeah. Okay. So 1, 2, and then another SYL there, SYL, and then that's it. Percent syl dot size. Okay. I think there should only be 3. Yeah, so there's 3 syllables, and that's what it's returning. Okay, no, that's it. That's a function. Every time you call make name, it's going to give you a name that comes from these guys. Now, what we can do is that we can just run this program, but on the is it possible to compile this program without running it? Because if you run it now. Actually, let's just do another for loop after that. It's not going to do anything. We don't have any cout statements, right? So do another for loop after that and print out the first 20 items.
I have a question.
Mm-hmm.
So is it possible to make your own macro? Because I'm sure that calling the function many times adds some overhead, and that could really add up with this super.
You mean you want a macro there?
No, I'm saying, like, is it possible to make your own macro, like how you can make your own methods?
Oh yeah, you can make your own macro. You can make a method inline. It's called an inline method. An inline method will basically just get inline. It's better than a
Because
macro.
I actually wonder if that makes it execute faster in this case.
No, it depends. Many times, if you inline a method, your code size will be bigger, but it'll be faster. Maybe it'll be marginally. I don't know. It depends on the situation. All right, it's not guaranteed. But you can exercise good judgment there, for sure.
Cool, because I do know calling adds some overhead every time.
Yeah, sure, for sure. All right, so go ahead now. Print out the first 20 items. Oh, you did print out the names. You print the names too, right? Oh, I can't see the. Yeah, okay. Yeah, it sounds. Well, no, why you're getting the same. Why the IDs not increasing? The IDs need to be increasing. So yeah. Oh, you're not setting the IDs. Previous ID equals ID. No, not previous ID equals I. Previous ID equals ID. Previous ID equals persons. You need to get the previous ID. Peter. Oh, he's here. Oh, still not Peter.
So maybe I can copy this code, and maybe later I can see if I can turn this into macros, see if it runs faster.
No. That's not the reason why it's printing slower. It's just it's compilation that's taking slow, less time. All right.
I just thought because 100,000 times it looks like it's going to be complex. That's why.
No. This is just a very really tight loop, right? So.
Oh yeah, so it's blindingly fast, right?
It is, we're not worrying about optimization at this point. We just want to get the logic right. Why? So yeah, all right. So the numbers all seem to be steadily increasing. That's what we want, right? Okay.
I think we might have to add a 1 to line 22 because there's a chance that the rand module 10 could be 0. And
yeah, no, we want that, right? Because we just want a non-descending order. We don't want an ascending order. Because when you sort a list, we always think it's being sorted in ascending order, but really it's not being sorted in ascending order. It's just being sorted in non-descending order. We just want successive elements to be not less than the previous one. It's going to be equal, because otherwise there's no way you can have duplicates.
Oh, okay. Gotcha.
So this way, the algorithm you develop will be more general purpose, because that's more realistic. All right. So now what we want to do is in the main method, you can comment out the for loop that prints out the first 20 items, right? That's just diagnostic for us. You can comment it out. Now what we want to do is get into a loop where we ask the user enter an ID to look up, right? So you have to, you can do an infinite loop there if you want for now, right? So yeah, well, true. You want to have, here's the things we want to do, right? Up to you guys to code it up. You guys can call out the code and code it up. So here's the things we want to do. So we want to ask the user, what ID do you want to look up? Right? And the user says, "Oh, I want to look up ID number let's say 75,412 or something like that, some weird number, right?" So you take that ID and then you're going to search through your list vector, one item at a time until you find the ID, right? If you find it, then you say, "Yes, here's the name of the person that with that ID." If you don't find the ID, you got to say, "No, that person does not exist." How do you know? Right? Here's a question I ask, right? So, and you should feel free to chime in. How do you know when the person you're looking for or the ID you're looking for is not in the vector? How do you know that?
Well, it depends on the search method that you use.
Linear.
Linear. Oh, okay, linear. Then if you just index the entire vector, and the person hasn't shown up.
So is there a better way to do this? I mean, that is definitely a good way, right? So it's not a good way. It is definitely a working way.
Well,
certainly, right? Is there a better way, another way to do this?
Yeah, well, since it's sorted, you can probably, well, since it's sorted from least to greatest, you can probably use that. Maybe, I don't know, maybe, I remember there was this sorting algorithm I heard about.
No, just don't think about any algorithms you've heard about, right? So let's think about what we have and imagine what you would do. If I ask you for ID number 75,000, right? And you are scanning the vector from top to the bottom, what would you do? As a human, what
I would probably look for the closest number to that, and then
when would you decide to stop? When would you decide to say, "I'm not going to look more. I'm going to tell that user immediately"?
Well, when it becomes greater than.
Yes. Thank you. All right. So that is the crucial bit of very important knowledge that Many people, right? You'll be surprised. Many people miss is that linear search is not always got to be the worst case. It's linear, but linear meaning on average you only have to search half the array. So people always think that linear means, oh, I have to search n items, right? No. So I bet that, right? So you go and ask other people, right? Other people in other CS2A sections or many people. When you say linear, they're saying, oh, it should take you should examine all n items. No, it's on average, it is something that is a linear function of n. It could even be 0.1 n, right? But if it's linearly related, so the thing that many people fail to exploit is that I have to look at all of the items before I say no. I can't. No, an intelligent programmer like Nate could say, no, I don't have to look at all the items. I've come to 75,001, right? And I haven't found 75,000, which is what the user wants. And every other item that I'm going to encounter from now on has got to be greater than 75,000, right? Because I've got 75,001, everything else has got to be greater. So I'm not going to examine the rest of the vector. I'll just say no right now. So that's a very, very important point. And that is supposed to be exploited. It's not supposed to be, right? That is good to exploit in our linear search. Lots of people don't exploit that linear search. And even when they know that they can't find the answer, they'll keep slaving on, right? So even when you found what you want, you keep slaving on until you die. And that's really what happens with many of the algorithms out there, right? When the
actually, that's what I actually, when I do searches like that, I do stop when I see it.
Yeah. So there's always this point that
feels like common sense to me, but yet I find it very shocking that people don't do that.
No, and it's not something to be shocked about, but I think that it's not something that is immediately obvious, right? It's not immediately obvious, because if you ask someone, they'll say, if it's not there in the vector, it's not there. Right, and they'll basically look through the vector, but they'll find out, right? If they just implement it one time, they'll know, right? But the thing is, many people haven't implemented it even one time. So if you haven't done it even one time, then you'll think you have to look at everything, right? Everything. If you've done it one time, you'll know. And that is the real risk when people try and tell you to do things that they have no idea how to do themselves, right? And then they tell you to do inefficient things. And all right, so what we would need to do now is basically enter an ID, get the ID, and we're going to do a linear search. And then up above main, you can write a function called linear search, which takes an ID. We'll do that function and then we'll come back to this, right? Because you know what to type in, right? Because I don't need to be here even to complete this part, the main part, right? So let's do the linear search up there along the lines that Nate suggested, right? Along the lines that Nate suggested. So so say what was it? Size t. It's going to return a size t, and say find person. Linear, that's good. Linear, what you type was good. Yeah, find person _ linear. Yeah, okay, good. Yeah, cool. Robert is actually already thinking ahead, because he's thinking, we're going to use the same code, right, next time to turn into binary search. Yes, because that's what we promised to Peter to do last time, right? As Peter said, it's useful. We'll just run the same code. And it's actually working out really nicely, right? Because we can use this code, right? All right. So what we want to do is, size t ID, and also you need to pass the vector, because the vector is private to main, right? So you need to pass the vector, but the vector is a big ass vector, so you can't pass it by copy. It'll be very wasteful. So you say vector of person, and then you have to pass it by reference, because so persons. You can call it whatever you want, comma. Because it's passed by reference, you also make it constant so that this guy doesn't get a chance to, mess with it. Yeah, const. Okay, all right. Now inside of this, it's really, really simple, right? To write the thing. So this is the ID you're looking for. So you say for I = 0, I less than persons.size, I = 0, I less than person.size, I ++. Right? And then if persons of I dot name and dot ID, ideally someone else should call the code out here, right? Because it's very it's a nice juicy opportunity. I shouldn't be taking it from you, right? It's a nice way for you to do this. If persons of ID = ID return I. No, you also need an else, right? You need an else. Then you have to incorporate Nate's condition. Otherwise, you're going to search the entire array. Yes? So, in fact, Nate should chime in here. Else should be an else if, right? Else if. Else if. Then you say, if persons of I dot ID is greater than ID, then you have to return a sentinel. Now, you'll notice that this function returns a size t. Now, what is a sentinel for size t? Every integer is a size t, right? So so what we're going to do is we're going to define the maximum possible size t as your sentinel, which means that you're going to say that there is never ever going to be a vector entry that is actually the maximum big ass number. This big ass number actually has a name. It's called standard std double colon NPOS. NPOS stands for no position. No, it's actually lowercase, right? It's in NPOS stands for no position, right? It means you're asking someone, yeah, if you're asking someone to find a position and they say, there is no position, they'll actually return this value saying no npos. So, and this is actually often returned by string functions, right? When you say
when you use dot find, if it isn't in the string, you check for no npos, no position.
npos, right? Yeah. And the string npos is basically just an integer. It's just an integer. In fact, npos is basically 2's complement. It is basically unsigned. It is the maximum number minus 1. It's basically all bits 1. All bits 1. So, and if you print out the value of npos, you'll see it's FFFFF in hexadecimal, right? It's all ones. Basically, it is the 2's complement of -1. And you don't have to write it down. It's basically the maximum number. It's a maximum possible number, and we basically sacrifice that number, right? When using size t, we sacrifice that number as saying, well, you know what? We strictly don't have 2 to the n minus 1 patterns. Well, we don't have 2 to the n patterns. We have 2 to the n minus 1 patterns, because the 2 to the n pattern, we're going to designate that as a special pattern we'll never ever encounter in our real data. Does that make sense?
Yeah.
Okay, so that is why one of those integers itself is a sentinel. A lot of people, don't even know that integers have a sentinel, right? So you can actually use that as a sentinel, and you can use the entire power of integers and not have to throw and mess around with exceptions. I mean, otherwise, the only other way you can signal back to the user you didn't find something that you asked for is basically by throwing an exception, right? Because you can't. There's no other way, right? You can't talk to the user, right? This is a ground floor mechanic, right? They can't talk to the user. This is a might find method. So there's no way it can signal things back to the user, the caller, saying I failed in my job. They have to throw an exception, and throwing exceptions is a right pain in the neck. So you don't want to do that. And this is a really nice way to exploit that and keep your code simple, easy, succinct, easy to understand, easy to process and maintain, right? Just by returning the right value and by using a sentinel. The sentinel is defined for you already. All brilliant people that design C++ use the sentinel, right? So we might as well do the same thing that brilliant people do, because they're probably doing for a good reason, right? And actually that good reason works for us. So we just say return npos. All right, so, you have to use names.
You don't actually need the std
string
double colon,
string colon npos, all right? String.
Oh, okay, yeah.
It is string colon npos. This is defined in the string namespace. string.
Oh, and I know you forgot a dot ID.
Dot ID on the persons of I dot ID. All right, so does it make sense? This is your entire linear search, and at the end, what happens at the end? You've gone through the entire for loop, and you've not returned any value so far. What does it mean?
That means,
at the end, before the very final square, before the very final, there. No. If you return 0, it means the thing that I look for is in the zero index. So what does it mean? What does it mean if you got to if you got to that place, it means you didn't find it, right? That means you actually searched the entire vector and you didn't find it. Yes.
Yeah.
That means you have to return string colon and
yeah.
Yeah, okay, that's it. All right, so this is your linear search method. That's it, like 5 lines or 10 lines, right? That's it. And if, in fact, at this point, if you complete the rest of your main method and basically ask the user to, type in an ID, I bet that, and you're in a loop, right? So you can be in a loop and say, try number 1, try number 2, try number 3, and so on. I bet that if I ask 10 consecutive numbers, you'll hit at least 1. Yes? So you're guaranteed to hit 1. So we can find out right now. So you can complete the method. What time is it now? Oh, wow, we got a half hour, right? Almost a half hour, right? It's only 9:20. Is it 9:20? 9:29. No, 9:25. No, I can't read the iPad. It's so far away. So, is it 9:25? Oh.
You're missing something on define person linear. You're missing your vector persons.
Professor, could I ask a question about the
sure.
linear function?
Yeah, go for it.
So we do in the find person linear, we do the persons of I dot ID. We do that
Mhm.
twice. Would it be faster in the code to like have that be called to like save that as a
Oh, I see.
person?
No, so in this
Well-
particular case, yeah. So in this particular case, it is actually not faster. In fact, in general, Ryan, it's better to leave these kinds of micro optimizations to the compiler, because the compiler knows the architecture, the chipset much better than we do, right?
Mhm.
So the compiler for this computer might optimize it slightly differently. It might actually move it into a register. Another compiler, which is optimized for ARM, might say, well, if you're compiling it for this architecture, you shouldn't move into a register. You should actually move it, leave it in the memory location because it's faster. On an iPhone, it might say, no, you shouldn't leave it in the memory location because it's a solid state. We need to bring it into hot RAM, right? So all these micro decisions, how do we know, right? There's so many little details. And so what I find is that if you want to, let's basically this kind of incredible knowledge, about what to optimize where is really a fine art. And it's impossible for us as programmers to master it. So there have been brilliant people who basically distilled it into the compiler theory. So the compiler does all of these incredible things for us, and I find that many times it's better not to work against the compiler by suggesting things that it would not have done itself. Yeah. So these things I find. But you're saying in this case, right? Is you just someone needs to mute, right? Someone's got a blender on.
Yeah.
All right. So in this particular case, you're just dereferencing a structure, right? So no, this is actually it's the same as dereferencing any other memory location, right? Because it's basically the person is, well, how many is it? Size T and the string, right? 24 plus, I don't know, 24, size T is 4 bytes. So is it 4 bytes? Yeah, okay. So 28 bytes. So it knows it's 28 bytes. Every time you're referring to that, it knows exactly which memory location it is. There's a direct translation right there. So I don't think it's any, it biases anything. If it does actually make the code more succinct by saving us 2 lines, that might actually be nicer, right? It might be worth thinking about, because you can say, oh, using that idiom, I can actually shorten my code. But that's a very good question to ask Ryan. Okay, so in this case, Ryan asked, is it less efficient to do the .id 2 times, basically dereferencing it 2 times, or is it better to fetch it once and store it in local variable, right? And my response, which you should absolutely check out if it's true or not. Maybe it's completely wrong, right? Is that the compiler knows. The compiler knows, based on the architecture it's compiling for, whether it's more optimal to move a particular memory location's content into a register or leave it there, right? In this case, it is basically memory location. Whether it's an individual variable or it's a structure member, it doesn't matter. It's basically the same, because it's right. So the question is whether you should move it into a local variable here or not. And it's a very pertinent and a valid, nice question to ask. Thanks. But nice question to ask. But did that answer your question though?
Yeah, that answered my question. Thank you.
All right, thanks.
I have another question. I mean, why do we make find person linear return the ID? It doesn't make sense. I mean, we already know the ID.
Yeah.
Why not just return both?
Shouldn't. Thank you. Who said that?
Robert.
Rob. Yeah. Thanks. You shouldn't return the ID. You should return the index. Index where it found.
Yeah. Okay, I see.
It should return the size T, and then it should return the index.
Okay, I see. That's the index. Okay.
No, not size IT. Size T. You got to type.
Oh, sorry.
Okay. And then no, where it returns. Oh, yeah, returning I. That's fine.
Yeah, returning I. Okay, I see.
Right, and then you can basically print out. You can print out the name of the person at that ID. Right.
Okay.
Is everybody okay? Right.
This makes sense to me.
Is speed okay with you guys?
Yeah.
Yeah. Well.
Peter? Yeah, go on, Peter.
No, I'm not done figuring out why it's wrong. I just.
I think you might have forgot the dot name.
Okay. Yeah, thanks.
Oh.
Yeah, there you go.
No,
No,
after the
percents.
index.
Oh, I'm sorry. Person's dot name. I'm sorry. Yeah, there you go.
Yeah.
Thanks.
Oh, thank you, Chad. All right.
Oh, remember that?
Increase
never
the
mind.
size of the code, the width of the code thing, and reduce the size of the terminal. Reduce the size of the terminal, the vertical bar. Yeah. Okay, cool. That's great. All right, and if ID not found, if ID found is not equal, if you else, right? And basically you can else. You can say name not found, or ID not found. Yeah. I'll try again. And then let's have the equivalent of an of a round number or something that we increment and print, so that we know, right, how many tries we're taking in order to identify a number, right? So let's have the equivalent of. You can basically just turn it into 4. But yeah, no, turn the 4 while into a 4 and make that 4 size t for size t j equals 0. Or size t j equals 0. J equals 0, semicolon, and then another semicolon. Basically, another semicolon right there, meaning that you're not going to, you don't have a condition at all. In fact, no, I don't know if you can have you just say true. It's between the two semicolons, just say true. I think you need it true, but what's checking the syntax? Why does it say? Okay, I think it's just a blank. Just a blank. Because true is a valid statement, right? No, just get rid of the true. True is a valid statement.
Yeah, I think you could do it without any.
Yeah.
Any statement there.
Yeah, no,
Yeah,
I agree. It works without anything in there. But I'm just saying true is a valid C++ statement, right?
I know you can put
one works.
You should be able to put 1 in there. That's
but
weird.
True also works. But true is the same as 1, right? True should work.
Yeah.
Why is true is getting underlined?
Huh.
In fact, that is supposed to be a true, not even supposed to be a 1, right? Because that is supposed to be a Boolean condition. Now I get rid of the true. But I'm just saying it doesn't make sense, right? Something is wacky there. Something is wacky either with the compiler or the IDE.
Yeah, it's IDE.
Yeah,
it works.
It's true.
Yeah, true works.
Yeah. Oh, it works?
Yeah, true works.
Okay. Right. Well, you can get rid of the true because I think the standard idiom is not having anything there. Yeah, okay. So that means you have this, and now a J is your round counter, right? So enter an ID, and then before enter an ID on line 41, you can basically, before the first left shift, or after the first left shift, or before the first left shift, you can left shift J plus 1 within J plus 1, and then, J plus 1.
J plus 1.
Within, and then period before the enter, period space before the enter. Okay, I think that should work, right? Although I think in the past we put J plus 1 within parentheses, but apparently this seems to be fine. All right, now if you run it, I bet. Yay! Okay, now increase the size of the terminal so that we can play around with it for a bit. Yeah. Okay. Now let's say I want to enter 75,000. 75,000. Not found. All right. And I bet that within 10 hits, I will find someone. I am guaranteed to find someone within 10. Yes or no? If I know 75,001.
Yes.
Yeah.
2001. If I just go in steps of 10, I'm guaranteed to find 1. And if it's steps of 1, I'm guaranteed to find 1. But the challenge is finding it in less than 10. Right? So let's try 75,005. Because otherwise it's boring, right?
There you go.
Hey, look, I found it in 3 hits. Now it didn't take me 10. Okay. Yeah, okay. Someone else take a shot. A different number somewhere else. Hey, Solare. Hey, the names are pretty cool, right? The names are pretty cool. These are just names of musical notes, and they're turning out some pretty cool names here. Yeah.
There might be a way to capitalize the first letter if it's on the first syllable, right? When returning.
Yeah. I think that's something we can do. Yeah, the first syllable you can. Yeah, absolutely. Yes. But Very nice though. But anyway, I think we've got the guts of it here. Yeah, we've got linear search going. And I don't know what were we going to do. We did linear. Oh, yeah, we can do binary search. We got it. We got 20 minutes, right? We got 20 minutes. Do you want to do binary search? You guys want to do binary search, or do you want to?
Yeah. Isn't the way that binary search works? Doesn't it work by splitting the list into two, and then I think, and then comparing the middle part with the number, and then going in the direction
Hey,
based
how
on
about
that?
this? How
Or is
about
that
this?
a different
Let's forget about what is commonly called binary search out there. What we'll do is just forget about what we're supposed to do and just do it in a more efficient way, which will actually end up to be the same as binary search, right? Is that okay? So here's what we're going to do. Nobody said okay, but here's what I was thinking.
Yeah.
Right, we know it's all sorted. We know it's sorted. So what we'll do is, instead of looking at one item at a time, starting from the beginning, we'll just take the middle item all together, right? Middle item, and see if that ID is equal to, more than, or less than the ID we're looking for. Yes or no? Right?
Yeah.
So based on the answer, we'll know if we've already found what we're looking for, meaning the ID is equal to what we're looking for, or we'll know this ID is too much, this is too big, right? Which means what you're looking for cannot be found below, it should be found above, right? Which means that the bottom half can basically be eliminated. I don't need to search the bottom half anymore. Yes? So we just reduce the amount of searching I have to do from 100 to a 50, 50%. Half the search space has basically been cut out. I don't even have to search. How incredibly cool is that, right? Now we'll do the same trick with what we do have to search, which is the top half, right? We just go to the middle and ask the same question. And every time we ask a question, we're basically getting rid of half the search space. Yes?
Yeah.
Yeah.
Okay, so if we keep doing that, then no matter how big we start, right, we'll get to this really, really quickly. How quickly? We'll get to that space, the target logarithmic exponentially quickly, right? So that's called log time. Log is the opposite of exponent, right? So meaning that every time we're eliminating half, so we go from 1024 to 512, right? 512 to 256, 128, 128 to 64, 64, 32, right? And half each time, then we find that, from 1024, I only need 10 examinations, 10 of these questions to ask. I only need to ask a maximum of 10 possible questions before I either narrow it down to the person that I want, or I can guarantee that the person does not exist, right? Only 10. I have 1024 persons here in my vector, but I only need 10 questions before I can find out for sure if a person exists or not. How cool is that? Right? So 1024 to 10. And that just log to the base 2 of 1024 is 10, right? that is the power of binary search. So we can try and do that now. So where's your binary search function? So all we need to do is, in your binary search function, and again, we're not following template here. We just wing the code, as I say, right? So what we want to do is find the middle point, right? Middle point of the vector, because that's the place where we want to check, right? So mid, let's say size t mid equals percent size equals divided by 2. Mid, size t mid divided by 2. All right, so that's the middle guy. Now we can find out if the middle guy's ID is greater than the ID we want or less than the ID we want. Yes?
Okay.
Yeah.
So do the comparison. If persons of mid dot ID is less than ID, then we know that
No.
make a comment there. Make a comment, right? Double forward slash. We know, top half can be ignored. Yeah, and then do a similar thing. Else if mid.id is equal to greater than. Else if mid persons of mid.id is greater than. ID, then bottom half should be ignored. Does it cover all situations? Yeah, great. Okay, that is so. And Robert says, in fact, you can put the return ID on the next line because the other two else's and the other two conditions come on different lines. So the return mid can also be on the next line too. Look nice. That's fine. So what's Robert's done here is if it's not greater than and if it's not less than, then it is guaranteed to be equal to, right? Because there's no other way, right? It can't be it can be not all three, right? It's got to be one of those. So it's not either of those, then it's got to be equal. So it returns submit. Now, however, this only works if we do it once, right? So what we want to do is if we're going to big list, we want to this is just one of the iterations, as it were. So if it happened to be the mid, it returns it. If not, then we have those two other things that we have to fix, right? Those comments we have to fix. So we know immediately that after, let's fill out the top comment first, right? And then the bottom one we can do later. So after the top comment on 29, hit enter. So here, what we can do is write another comment saying our target lies between 0. Our target lies between between 0 and the top half can be ignored, right? So our top half, our target lies between ID plus 1 and the end, ID plus 1 and the end, right? Because the top half can be ignored now between ID plus 1 or persons of ID plus 1 or whatever, however you want to say.
Wait, mid plus 1, right?
Yeah, mid plus 1. Thank you. And the end or not, maybe the or does not exist, right? Or does not exist. That's a possibility, right? And likewise, put a comment there for between 0 and mid minus 1. Yeah. So far, are we in agreement?
Yeah.
Okay, so now that means that if the top half can be ignored, what we want to do essentially is rather than calculate the mid, so here's the change that we want to do. Hey, Robert, can you move the code up a little bit so that actually, you know what? I'm zoomed out. No, you're right. I'm actually zoomed out. Yeah. Okay, this is much better. You leave it as it is, right? So we're going to do something very important here. We know that mid is being calculated as a middle point of the search space, right? But it's not always a search space if we're going to call this function on chunks of the vector rather than the whole vector. The way this function is set up is that it always searches the whole vector because we're doing 0 and vector.size, okay, and dividing by 2 to get the midpoint. But that's not what we're after. We want to search a range of that vector, right? So what we want to do is rather than at the top, we want to do before size t mid. No, we don't. Let's not make it recursive, right? On the next line.
Oh, I see.
Yeah, that's fine. Size t low equals 0 and high. What is it? Persons size minus 1. Oh, is it persons size? Actually, it should be persons size minus 1. It's the last index, right? Persons size. Yeah, okay. Now mid should be low plus high over 2. Was it low plus high? No, high minus low over 2. High minus low. Is it? Actually, no. It is actually low plus high over 2, right? Because what we want is basically low plus half of the difference. This is low plus high minus low, which is the difference over 2, right? And so if you simplify that, it's basically low plus high over 2. But strictly speaking, low plus high minus low over 2 is the correct one. There's a better way to do it, but we won't do it now, right? Because it's more intuitive right now, right? So mid equals size, and it's fine. Okay, so now that means after the comment, our target lies between, right? After the comment, now we can say low equals mid plus 1, and high equals. You don't have to change high because only low needs to be changed, right? You don't have to change high. And likewise in the other one, you need to say now high needs to be changed. High equals What is it? Yeah, okay, mid -1. Now, now we know that everything is set up so that it can operate on not just the whole vector, but even chunks of the vector. I'm really, really, really afraid that I'm losing a lot of you because we're walking a really tight rope here, right? I just want to make sure that everybody's with me, right? This is a really risky place, and a lot of people can't drop off.
I think I get it.
Uh,
Oh yeah, no, I get it.
I think you might have swapped low and high on
What time is it
these.
now? All right. Do you
Oh,
wanna-
never mind. I meant
Yeah, I think what all right, how about this? How about this? All right. We can wrap this up next class. Not a big deal. You can wrap it up in 10 minutes or after class if you want, our Discord channel, Slack, and wrap it up on your own. It's fine. Or I'll wrap it up next class.
Why do we say mid is equal to low plus high? Couldn't we just say mid is equal to high divided by 2?
No, you can't.
Because
no.
low changes. Yeah.
Okay.
When
This
it's
is-
zero, when
question.
it's zero, yeah,
In
it
fact, that is a
is.
very good question. Who asked that question, by the way?
Peter.
Peter, actually, that's a very good question. Why should mid be?
Oh, I see. Load changes here at equals mid plus 1. Gotcha.
Yeah.
Then it runs through. Oh, wait, but that only changes after the code runs. We don't have a. Yeah, wait a minute. Whenever it hits mid, when would low ever be not 0? When we set the mid.
Oh, I see. Yeah. Low will be 0 when we start, and high is going to be person start size. And this is not complete, by the way. This is a loop. This needs to be a loop. Right?
That's what I'm missing. Okay, it looked like it was set up like a loop, and I
Oh,
was like,
sorry. Yeah, I was
interesting,
hoping that you guys.
but then it wasn't.
Yeah. I'm sorry. Thank you, Peter. All right, let's do the loop. Okay, but I think it's more confusing than not. Okay, so do a loop. The if statement basically. Yeah. Above the. Yeah, there you go. While true. Yeah. Okay. Yeah, I think.
Okay, we'll keep true for now, right?
Keep true. But strictly, you only want to compare until such time as low has not overtaken high. Essentially, your
Right.
high is approaching mid and low is approaching mid, and you want to stop as soon as low is greater than mid. So you can say while low is less than mid, low is less than high. While low is less than high, you can keep in the loop. Less than or equal to high. Less than or equal to high. Yeah.
Gotcha. Okay, that
Right.
makes sense.
And then you're in the loop, and basically, is that it? That's it. Oh no, what happens if you don't find it at all? So you have to string return npos right at the end. You have to return npos at the end.
Right now you're returning inside the while loop. Is that
Right now you're returning. Yes, valid. Yes.
okay?
Yeah. Inside of the loop, the ifs return valid indices, and if you cannot find it, mid lowest and lowest crossed over, and you still can't lows equal to low. Well, I mean, there's corner cases here that you have to verify in your mind. Run it. Right, we're not going to run here, right? I'm not going to run it and look at the bug and then we'll fix it together. That is a really, really juicy opportunity. I want to leave it to you guys, right? So we can do it. If nobody's done it, we can do it next class. It'll take us about five minutes at the beginning of class. We can do it, but ideally, I would like one of you to do it and basically share the code like you've been doing, right? Share it on Reddit and repeat. So usually only 1% or 2% share it. Right? I'd like more of you to participate and share. But I think this would be a great opportunity. And this is what we plan to do today, right? We plan to do linear search and binary search. We did both. And then after we do recursion, we'll try and turn the binary search and the linear search, both of them, into recursive methods, right? We'll turn them both into recursive methods. And we'll look at the pros and cons and say, oh, is it worth turning binary search into recursive? Is it worth turning, why do people do recursive at all? Why do people do
That is a good question that I've never known the answer to.
Yeah, so bring that up next class. Bring that up, and we'll be. We've talked about this many times in past videos. You can look at past videos, recursion, corresponding weeks in the previous quarter. I'm pretty sure we'll talk about recursion and motivation for recursion and stuff like that. Ideally, you should watch those videos before you come to class. But certainly next Tuesday, we'll talk briefly about this before I disappear for a little while, and we'll take it from there. Right? I think it's about time. For your next class. Is it 9? It's 9:50. I am supposed to let you go at 9:50. We don't have to go, right? You can basically hang around and basically have a conversation amongst yourself. Ask me questions. I'm happy to chime in but I'm not going to help you with the code anymore, right? So you guys call out the code yourself. I put in the code. Don't make any
So
changes.
can I finish the binary search?
Don't finish it off, okay? Chad, no, you can't. No, Chad, you're not allowed to take the screen, especially when I'm not around. So you and I.
I'm just saying, on my free time.
No. On your own, you can do it, and then you can share it. But no, not on the screen, okay?
No, I'm not saying on the screen. I meant someone else.
Yeah. Totally. Someone else should basically finish it off, and
Like maybe I'll finish it off, away. I copied and pasted the code or try.
Yeah, totally. Everyone should, not only you, right? Everyone should take a copy of the code, try and finish it off on your own.
And I think here you just implement, you just iterate through, right?
Yeah, no, not in binary search. In linear, you iterate through. In binary, you in each iteration you have to chop off half. Yeah, you have to iterate through and chop off half each time, and it'll work. It should work, right? And if it doesn't work, debug it a bit and find out and discuss it. If it doesn't work, discuss why it doesn't work in the forum, so we can help you. Okay.
I'll see you later.
And help you guys. Okay. So thank you so much. Was this a useful class? We actually did cover some material, right?
Oh yeah.
Good.
There's a lot here that I learned, so that's good.
Yeah. All right. Thank you, Peter.
Yeah, structs are cool. That's a cool part of C++ I didn't know existed.
Yeah, I was a little concerned that we spent a lot of time, waffling. I was talking about a lot of stuff not directly connected to CS2A, but we actually did end up covering everything that we planned to do. So, which is a pleasant surprise for me. So that's great. Thank you so much.
I think what's actually extremely helpful for me is that when I watch you code or when I watch you instruct code, you put a lot of implementations in place that are temporary implementations, just help debugging or something like that, like a for loop that's infinite or something like that. And to be honest, I'm the kind of person who tries to like make it perfect and like run it all in one go, which never works, obviously.
Never worked for me. Yeah, never worked.
So yeah, it's good to see like strategies for like, because that's not what's normally taught in a class, right? You always get like these formulas of like, here's how to do an if statement, here's how to do a for statement.
No, I did that way. I did that way for a very long time. Long before you. I think 2 years ago. 2 years ago, I did it that way, where all my assignments were people would do the product and finished product and submit the final code, and I'll look at the final code. And lots of people were really struggling, just like you said, right? Because they think that they have to do the finished thing, polished final thing, or nothing's going to work.
So yeah, good to see like examples of like things that I can do as I'm setting up the code to sort of like debug it temporarily, like having a for loop that's like, like you're not going to leave that in permanently, but it's just like a thing so that you can see how it works before you actually implement a real for loop.
Yeah, I find that.
So yeah, those are good to see, I think.
Thanks. All right, we'll keep more of that, going forward. And so next Tuesday, Nate will be leading most of the class. Thank you very much, Nate. And I'll see you at 8 o'clock next Tuesday, and we'll take it from there.
See you.
All right. Then I'm gonna leave now. Bye.
All right. Thank you, guys. Thank you guys.
Thank you.
All right. Bye.
Okay, bye.
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 Bye.